Right. Hi, everyone. So this lecture is on classification of matter. Uh, the we've been talking about matter contains mass and volume, right? Something that has mass and volume. Uh, but we need sort of ways to describe the different types of matter. So we have a we call a classification system here, and we can break matter down into different categories. So the diagram up on the top sort of walks you through all um, the different ways we can break matter down. Okay, so what I'm going to do is kind of walk through this and explain the differences between them and how you get um, down to figuring out what each one is, type of thing. So the first split for matter, okay, matter can fall into one of two categories, either a pure substance or a mixture. Okay, the pure is in parentheses here because sometimes you'll just hear it called a substance. For what we're doing, I'll call it a pure substance all the time, just so there's no confusion. Uh, okay, so what is the difference between a pure substance and a mixture? Well, if we look down here, we've got definitions. A pure substance is made of only one type of material and has unique chemical and physical properties, whereas a mixture is two or more substances not chemically combined and put together without a fixed ratio. So up here, a pure substance would only have one type of thing in the whole sample of whatever you're looking at. So now when we say one type of thing, it doesn't necessarily mean just one element, okay? Uh, it's just one substance. So for example, if you had a bathtub full of water, okay, and water was the only thing in the bathtub, then that would be a pure substance. Water is a pure substance. Okay, it's chemically combined, it's H2O, and it would be always H2O if the only thing that was in the bathtub was water. Okay, whereas in a mixture, things are not chemically combined. They're literally just mixed together. So um, if you imagine a mixture of like salt and pepper, okay, they're not chemically combined. They are just put together in the same area, but they're still separate things. Um, I'm trying to think of another example of gasoline. Okay, that's sort of a good example of a mixture because it all looks the same sort of, but in gasoline, it's actually a mixture of different things. It's a mixture of alcohol. I don't know how many people know this, but that the gasoline smell is actually a different compound that's added to it to make it smell. So that way people know uh, so that way you can smell if gasoline is leaking or if there's gasoline somewhere. Um, so gasoline is actually a mixture that's not chemically, like some of the parts are not chemically combined. Okay. So that's the difference between a pure substance and a mixture. All right, let's go over to the pure substance side. So a pure substance made of only one type of material can be broken into one of two things: elements or compounds. Elements are substances made of only one type of atom and cannot be broken down into simpler substances. Examples: carbon, helium, gold, sodium, oxygen, potassium. Essentially, elements is anything found on the periodic table. It's literally called the periodic table of elements. Okay. So if it's on the periodic table, it's an element. If it's not, it is not. Okay. Then the other thing it can be, a pure substance can be, is a compound. A compound, two or more atoms or two or more elements, chemically combined in a fixed ratio. So examples of this: carbon dioxide, which is like CO2, sodium chloride, hydrochloric acid, ethyl alcohol. I don't know what the formula for ethyl alcohol is. Iron 2 oxide, rust. Okay. Water would be one. Okay, now, chemically combined in a fixed ratio. What does that mean? Well, for example, we were just talking about water, right? Water is a compound because it's two or more elements combined to get chemically combined together. In a fixed ratio. To be water, the molecule has to be 2 hydrogen and 1 oxygen. Right? If we change that ratio, we don't even have to change the elements. If we change that ratio, so for example, if I wrote H2O2, right? I don't know if anybody knows what that is. It's not water anymore. This compound in that ratio, H2O2, this is actually hydrogen peroxide. That's the stuff that you can buy at like Walgreens or Walmart or whatever. It comes in it's a liquid, comes in a brown container that you put on cuts to help clean them and disinfect them. That's hydrogen peroxide. They're two totally different things. They're totally different because they are compounds and they have to have a certain fixed ratio. If you change that ratio, it makes it something different. Okay, that's for compounds and for pure substances. So, pure substance in your sample of whatever you have, it has to all be the same thing. Okay, so like, again, we can have water, but all water will be H2O. Okay, so it's like all the same thing throughout the whole sample. All right. Now, let's back up here, and we've got pure substance and we've got mixture. So mixture, as we mentioned before, two or more substances that are not chemically combined and put together without a fixed ratio. Okay. We can break a mixture into two categories here. So we've got homogeneous and we've got heterogeneous. Homogeneous is a mixture in which you cannot visibly see the different substances. It all looks the same. Heterogeneous is a mixture in which you can visibly see the different substances. Okay. The prefix homo and hetero in science, homo refers to same. Hetero is different, essentially. So like if you remember back to your bio, you had the like in genetics, you had homozygous and heterozygous for the genes. Homozygous is where you had two of the same, either both capital, both lowercase, whatever. Heterozygous is when you had one of each. Okay. Homogeneous means all looks the same. Heterogeneous, you can visibly see the different parts. Okay. So examples of homogeneous mixtures: Kool-Aid, salt water. Okay, think about Kool-Aid. You make Kool-Aid and you've got the flavor packet, you've got water, you've got maybe you might add sugar to it. Okay, so you mix it all together and you try the Kool-Aid, and it's not sweet enough. You like the Kool-Aid really sweet, so you add more sugar. Okay, you've changed the ratio, right? Okay, but it's still Kool-Aid. It didn't make it something different when you change that ratio. That's because they're not chemically combined and they don't have to be in a fixed ratio as a mixture. So other examples of homogeneous, like coffee, anything along those lines. There's some, so gasoline would be a homogeneous mixture. Okay, stuff like that. All right, heterogeneous, a mixture in which you can visibly see the different substances. So Italian salad dressing. Sand. Now, I put sand in there because sand can be kind of tricky. If you look at it from far away, it might all look the same. But if you were to look at sand a little more closely, you would see that you can actually see different types of little tiny, essentially little tiny rocks, like the little sand granules. You would see many different ones. Okay. All right. Now, we can sort of categorize mixtures even further as being solution, suspension, or colloid. Okay, I'm assuming you've probably heard of solution and suspension before. Maybe not colloid, we'll see. So, a solution. A solution is homogeneous mixture, meaning you can't see the different parts, cannot, where one or more substance or substances is dissolved in another substance. So there's a couple of terms here that you might see at some point, which I'll put. So a solute is the substance being dissolved and a solvent is the substance doing the dissolving. So if we have salt water as a solution, okay, the solute is the salt and the solvent is the water. So all examples, Kool-Aid, lemonade, one substance is dissolved in another one. That's a solution. A suspension. A suspension is kind of the opposite way. It's heterogeneous, meaning you can visibly see the different parts. It's a heterogeneous mixture that separates into layers over time. So some examples, orange juice, paint, Italian salad dressing. If you think about all those, if you let them sit, you get layers, right? In the orange juice, you get like layer pulp and then like more liquidy layer. Paint, depending on the type of paint, but most paints, especially oil-based ones, if you ever see an oil-based paint, like it'll separate into like the pigment stuff, and then like you'll get a layer of oil on top. That's why you have to stir it before you use it. Italian salad dressing separates into a bunch of different layers. Pretty much anything that says shake before using, like shake well before using, is probably some kind of suspension, because that means the reason they have you shake it is to mix it all up to get it kind of evenly distributed throughout the whole substance. Okay, so there's suspensions. All right, the third one, a colloid. Now we've got colloid here under homogeneous because you can't really visibly see the different parts, but they're not dissolved together. So it's actually, in a way, it's between a solution and a suspension. It's got properties of both. Okay, some examples of colloid are fog. So what is fog? Well, fog is actually tiny liquid water droplets that are so small that they can actually remain suspended in air. And you can't actually see the individual the tiny liquid droplets. But they are, um, but they're liquid, not gas. Fog is actually not a gas. Okay? Smoke. Smoke is similar, except smoke are tiny solid particles suspended in the air. So what happens is like if you think of like a campfire or something, the smoke that you see rising up, um, if something is a true gas or vapor, we really for the most part can't see it. Okay, so the reason we can see smoke is because what happens is um, when the wood or whatever it is that's burning, when it's burning, it goes through combustion, and it doesn't go through complete combustion. It goes through what's called incomplete combustion, and some of the byproducts of this include little tiny solid particles, like essentially ash. So if you think about ash, um, some of the ash particles are big enough that you can see them and they stay on the ground or whatever. Well, some of these little tiny solid particles that are residue are so small that they can remain suspended in air with air currents and stuff. And that's what smoke is. Which is why, if you think about, when they talk about like smoking, um, it's bad for your lungs. Um, just in general, inhaling anything that your lungs are designed to handle gases, oxygen, and carbon dioxide exchange, stuff like that. They are not developed to handle liquids and solids. It's why when you swallow down the wrong tube, you get something down like you cough. Coughing is your body trying to expel something that's not supposed to be in your lungs. So when you smoke something like a cigarette, um, yeah, there's gases in there, but there's also a lot of these little tiny solid particles. That's what smoke is. And so when you breathe that in, your lungs can't um, like process that. They're not developed to deal with solid products. So um, that's one of the many reasons that smoking is harmful to you because it's essentially taking something into a place in your body that isn't designed uh, to process or to deal with it. Um, so that's why when you get smoke in your eyes, it irritates your eyes too, because it's little tiny solid particles, um, that get in there. So that's a colloid. Smoke would be considered a colloid. And milk. This is the one that sometimes freaks people out. So think about the difference between like fat-free milk and vitamin D or whole milk. Fat-free milk looks like runny, kind of almost bluish sometimes, whereas whole milk looks really thick and white. The reason for the difference is is what's taken out of fat-free milk. Fat. In milk, there are, among other things, milk is a mixture, but there are tiny fat particles suspended in the milk. Okay, it's part of the milk, but like milk is made up of other things too. So, um, but there's tiny fat particles. You can't see the individual ones, but they're not dissolved. they're not actually dissolved in the milk. So that's why you see the difference. Now, if you look at all these, like, how do you know if something is a colloid? Um, well, if you can't visibly see the different parts, how do you know they're not dissolved together? Well, really, you don't unless you can somehow filter out. So um, think about like go back to the smoke in cigarettes. If you see the butt of a filter of a cigarette, there's stuff trapped in there, right? Well, that's because there's little tiny solid particles. You can't filter out something that's dissolved, not with like a normal filter. If it's dissolved together, it won't, like you run it through a filter, nothing's going to get caught. But smoke gets caught in a filter. That's because they're not dissolved together. Okay. So another way too is think about how light goes through it or doesn't go through it. Right? In a colloid, light will not easily pass through. Light will go into it, but what happens is the light starts hitting those solid or liquid particles, and it can't get all the way through. So think about driving in fog. You use your low beams, which are pointed lower, literally on the ground, than your high beams, because when you shoot your high beams into the fog, they start to penetrate, but then they can't get all the way through because they're hitting the little liquid drops. So they start bouncing. The light starts bouncing around and bouncing off the liquid drops. Well, what does that do? Well, it makes it kind of it kind of makes it glow in it, and it as the light bounces around, it doesn't penetrate, so it's hard to see through. If you were to hold a flashlight up to a gallon of milk, basically what you would see is it would almost make it glow. The light wouldn't pass all the way through because once it gets in there, it starts hitting the little solid particles and it starts reflecting around and bouncing. It kind of almost like quote unquote gets trapped, and the light can't make it all the way through. So that's another sort of property of a colloid. All right. Now, so that's essentially the breakdown of the classification of matter. Now, the last part we're not going to talk a ton about. There's different methods to separate mixtures, and it's based on whether they're homogeneous or heterogeneous. Homogeneous methods, like distillation by boiling point, like if you had salt water, you could boil off the water and the salt would be left behind because the salt has a different boiling point. Chromatography is where you separate pigments based on their size in a solution. Let me see if I can bring it up real quick here. So, here we go. Here's a picture. So this is an example of chromatography. Kind of a little blurry, but separating, and it separates them based on the size of the pigments as it goes through. Okay. Crystallization. So crystallization is where you get crystals forming out of a solution. You evaporate off the solution. Okay. This is actually how rock candy is made. Still giving it to me. Okay. So crystallization is when it forms a crystal structure. So the crystal structures for different, like they've got diamonds for different minerals and stuff. It forms when the minerals are dissolved in water, and then as the water evaporates out, the solids form a crystal structure. Okay. Melting point, kind of like boiling point, can filter out homogeneous. Heterogeneous, things you can visibly see the difference. You can filter them. Okay, we talked about that. Like, like think about coffee filter. It's based on the size of the particle. It filters behind coffee grounds and it lets the solution part go through. Magnetic. Okay, that's how they in recycling they pull scrap metal out, certain scrap metal to these giant magnets. When all the recycling comes in, this giant magnet passes over it and it separates out the metals that are magnetic. Mechanical, literally by hand, you could literally physically separate. You separate coins based on denomination. You physically separate it based on by your hand. Density, different densities. So like you have say you have a mixture of I don't know, it's gonna be something ridiculous. So you have a mixture of sand and so you have a mixture of sand and like little styrofoam pieces, and you want to separate it out. Okay, well if you pour it into water, the sand would sink to the bottom and the styrofoam would float, and you're separating it based on density. Okay, the key here is you cannot use heterogeneous separation methods on homogeneous. Like you cannot filter out salt water. If you have salt water, which is a homogeneous solution, and you run it through a filter, nothing will happen. The salt water will still be together. So you can't separate homogeneous solutions using heterogeneous mixtures, separating mixture methods. Okay. All right. Last thing is I'm going to kind of explain the last page on the homework that's related to this stuff. So it's the first page on your homework, but we haven't gone over it yet. So this is separating them out. Now, if you'll notice, they've got colloids here. Okay, colloids, it just depends on the book and the chemistry. Most of the stuff I've seen has colloids under homogeneous. It doesn't really matter. Colloids are in between, but just just understand that that's why that's there. All right, so classify each of the following, whether it is a substance or a mixture. If it is a substance, write element or compound. So pay attention to this. If it is a substance, write element or compound in the substance column. If it is a mixture, so you're writing that here. If it is a mixture, write heterogeneous or homogeneous in the mixture column. Okay, so chlorine. Chlorine is on the periodic table. That makes it a substance and an element. Okay, so under substance, you would write element. It's not a compound, it's an element. Okay. All right. Let's go down to one that can be sometimes a little confusing. I'll do 8 and 9 as well on here. Alcohol. I'll do 8. Alcohol. Okay, this is not talking about alcohol you drink. Alcohol you drink would actually be a mixture. It would be homogeneous because it's not just one. There's like a mixture of different things in it, so it's a solution actually. All right, this is talking about alcohol, like actual alcohol, like the rubbing alcohol or whatever, ethyl alcohol, like that. Okay, alcohol is a pure substance, but it's not an element. It is a compound. So under substance, you would write compound. Okay. If we were talking about alcohol that you drink, that's a mixture, we would have written under mixture, we would have written homogeneous because you can't see the different parts. So you had written homogeneous over here instead. All right. Okay. If you guys have questions, message me either through Google Classroom or on Remind. Other than that, I hope this helped, and good luck with your homework.